Most data analysts waste their time learning Python the wrong way. They sign up for some 50-hour course, start at lesson 1, and then they try to learn the entire language before they even touch a real problem. I did the exact same thing when I started and almost quit. So today I'm going to show you what to do instead. Why starting with endless courses is the slowest route left, how to build on a skill that you already have, and exactly how to use AI to cross that gap fast, including a verification step that no one else does. I'm Kedeisha, and 6 years ago, I was delivering pizzas and Amazon packages for about $8 an hour. I taught myself data analytics from scratch and landed roles across data analytics, data engineering, and data science. And since then, I've helped thousands of other career changers launch six-figure data careers without going back to school and courses that just don't work. All right, so let's start off talking about the trap, because you're probably stuck in it right now. If you've already spent nights and weekends working through Python courses, but still don't feel capable on using it on real data problems, it's easy to assume you just need more practice. But what if the problem is actually what you've been told to practice? Think about what learning Python normally looks like. You open a course and immediately start learning variables, loops, functions, algorithms, generators. You finish one lesson and then another and then another. And technically you're learning Python. But then someone gives you a CSV file and asks you a very analyst question like, which 5 product categories generated the most revenue last quarter? And then you suddenly freeze. You spent 20 hours learning Python, but you still don't know how to confidently answer a basic business question with it. And that is what I call the beginner trap, because Python is a general purpose programming language. It can be used for data analysis, it can be used for software development, automation, machine learning, web application, and a ridiculous amount of other things. So if your goal is to become a data analyst, you do not need to learn all of Python before you can become useful with Python. And this matters even more if you're learning this stuff while working a full-time job, because you don't have unlimited Saturdays. So when someone tells you just finish this 50-hour Python course, what they're actually asking you to do is spend weekends and months learning concepts without knowing which ones are actually going to move you closer to a job. And when you don't see progress, you start blaming yourself. Maybe I'm not technical enough. Maybe I'm too old to learn this. Maybe everyone else understands programming and I just don't. I know that feeling because I had it too. But struggling with a badly designed learning path is not proof that you can't learn Python. It might just mean you're learning Python as if your goal is to become a Python developer when your actual goal is to use Python to solve simple data analytics business problems. Those are two completely different goals. So instead of asking, how do I learn Python? I want you to ask a much narrower question. What do I already know how to do as an analyst, and how would I do that same thing in Python? That question completely changes the whole learning process, because if you already know SQL, which you should not be jumping to Python if you don't know SQL. You already know that when someone asks which customer spent more than $1,000 last year, you just need to identify the right table, select the right columns, filter the right records, probably aggregate something, and then validate the output. Python does not erase that reasoning, only the syntax changes, but the analytical thinking matches. So when you're learning Python, you're not starting from zero. If you can write SQL, if you can take a business question and turn it into a query that filters, groups, ranks, cleans, you already own the reasoning, and that reasoning already took you months to develop. What you're missing is the syntax, which means you're not necessarily learning a new language, you're just translating one. Okay, so now once you stop treating yourself like a complete beginner, the next question is much smaller. Which pieces of Python actually correspond to the analytical work you already know how to do? So here's how you start. Not with another Python course, with SQL. You already know why you're selecting these columns, you already know why you're filtering those rows, and why you're grouping the data. And you know why you're storing the final result. So now we just create a translation map. Select becomes selecting columns from a data frame. Where becomes a Boolean filtering. Group by becomes group by. Join becomes merge. Count, sum, and average becomes aggregations. Order by becomes sort values. And then case when can become np.where. Now, I don't want you to memorize that list just because I said it. That would put us back to the same problem. The point is to connect every unfamiliar Python operation to something your brain already understands in SQL. So when you see a group by, you're not thinking, great, another random Python method I have to memorize. You're thinking, oh, I know what this is doing. This is just a group by. That is a much smaller learning problem. And it also gives you a filter on what you should learn next. Because one of the biggest things that I see aspiring analysts make is allowing a curriculum to decide what deserves their time. The course may say object-oriented programming is the next module. So they waste even more time learning object-oriented programming. But the data analyst job description did not suddenly change because of what some random instructor said in module 14. Your goal is still data analysis. So your learning should always be driven by the problems that you need to solve, not the course that you take. So let's start extremely small. create a table with two columns. The first column, write a SQL operation. In the second column, write the pandas equivalent. Start with 7 operations you actually use, and that's it. You don't need a giant Python roadmap tonight. You only need a bridge between SQL to Python. And once you have that bridge and you understand it, then we just need to find out whether you can actually walk across it. 7 rows, that's it. That is the entry fee to Python, and you can build that tonight in about 20 minutes. Now, having a map can make Python more manageable, but familiarity isn't proof. So how do you test yourself without simultaneously struggling with a new dataset, a new problem, and a new syntax? This is where most people accidentally make learning harder than it needs to be. So they learn a little Python and immediately think, okay, I need to do a Python project. So they download a dataset they've never seen before, pick a business problem they've never solved before, and open a library they barely understand and try to write syntax that they've never used. Then the code breaks, and now they don't see what's wrong. Is the logic wrong? Is the syntax wrong? Is the dataset even dirty? Did the join duplicate something? You have too many unknowns at the same time, so remove them. Instead of choosing a new problem, choose an old one. Take a SQL query that you've already written, already tested on, and already know is correct with a dataset that you already know. So let's say your SQL query returns 437 rows and total revenue of $2.6 million. Now rebuild that exact analysis in Python with pandas. Not something similar, but the exact same analysis. So when your Python code runs, you don't celebrate yet because code running is not the test. Your result matching your SQL query is the test. Does Python return 437 rows? Does the revenue total equal $2.6 million? Does your group values agree? If yes, good. If no, even better, because now you have something specific to investigate. Maybe SQL ignored a null in a way you weren't expecting. Maybe your pandas merge created duplicate rows. Maybe the index changed something. Maybe you filtered at the wrong point in the analysis. That mismatch is where a huge amount of the actual learning process happens. And this is important because real data work doesn't reward you because your code ran without an error. You can write perfectly valid code that produces the perfectly wrong answer. And this is actually more dangerous than the code breaking, because broken code at least tells you that there's a problem. Wrong code that runs quietly lets you send a problem to someone else. So verification has to become part of what you already do from day one. Your fixed example might look like this. I rebuilt my SQL analysis in pandas. Both outputs contain 437 rows. Both produce a $2.6 million in revenue. The top 5 categories appear in the same order. Now I know the Python version reproduces the same result I already verified in SQL. Notice what happened there. You didn't ask yourself whether you feel comfortable with pandas. You created a test. It either matches or it doesn't. That's the difference between watching somebody code and knowing that you can code. This is a pass or fail. Now, this is usually the point where frustration hits. You've already been studying all day, and you know AI can give you working code in seconds. So how do you decide to use AI without outsourcing your thinking to it? Because this is where AI can either make you learn Python dramatically faster or make you dramatically worse at it. Because imagine that your SQL query works, your pandas code doesn't, and you just paste the whole thing in AI and say, fix this. It gives you an answer, you paste it in, it runs, and great. Except you learned almost nothing. And now you have a more dangerous problem at hand. You have working code that you cannot explain. And the next time the data changes or the code breaks or someone asks you why you use that merge instead of something else, you're stuck again at ground zero. So I want you to separate syntax from judgment. AI can help you with the syntax, but you should always own the judgment. For example, instead of saying, convert this SQL query into pandas, try, here's a SQL query that I understand. Walk me through how each operation maps to pandas step by step. Explain the reasoning as if I was 5, but let me write the final code. Now AI is helping you translate. It's not about doing the thinking for you. And there's an even more important version of this when your output is wrong. Now let's say SQL gives you 437 rows, but your pandas output gives you 512 rows. The easy prompt is, here's my code, fix it. Don't ever do that. You tell AI, my SQL result has 437 rows and my pandas code gives me 512. Do not fix my code. Ask me questions one at a time that will help me identify why the outputs are different. Now you have AI as your tutor. Maybe it asks you whether your merge keys are unique. You check. They aren't. Then it asks you what type of join you used. You check. Then you start understanding why your output expanded. You start doing the real analytical work. AI is simply shortening the distance between getting stuck and knowing what to expect next. And there's one final test I want you to use. Explain the code out loud. line by line, not what the syntax is called. Explain what it is doing to the data and why you need it in plain English. This line filters the data frame to active employees because inactive employees should not be included in this calculation. This line groups those employees by department because I need one result per department. This line calculates average salary for each group. If you get to a line and all you can say is, AI told me to put this here, you don't understand that line yet. So go back, ask what it does, change it, and see what happens. Then explain it again. Because AI has made it incredibly easy to create code that is above your level of understanding. And that gap is what I call comprehension debt, because eventually you will have to pay it. Usually when something breaks, or when you have an interview, or worse, when you're actually on the job and someone asks you to explain why the numbers are wrong, or why you got this result that you got. So use AI aggressively for the thing computers are great at, retrieving syntax quickly. Do not ever outsource your judgment or your thinking to it, because eventually you're gonna pay for it. The rule underlying both is the same. AI writes the syntax, you own the logic and judgment. All right, now once you translate SQL logic into verified Python without handing over your thing into AI, there's still one core question left. How does any of this actually become something a hiring manager actually values? Let me give you a practical example. Imagine every month you have multiple Excel files coming in. You have to open them, clean the same columns, standardize the same values, combine everything, and then refresh the same HR dashboard. And every month you repeat the same process. Maybe it takes 4 hours, maybe even 10. Now, someone asks you a simple question. Can we automate this? That is where Python becomes valuable. Not because you can put Python on your LinkedIn, not because you finish a certificate, not because you memorize the difference between a tuple and a list for a quiz. It's because Python is valuable because 4 hours of manual repetitive work can all be done in about 5 minutes. Now, every piece of code has a job. You're using Python to clean the files consistently. You're using it to combine data that isn't sitting nicely in the database. You're using it to automate repetitive transformation. You're using it to prepare the data so that reporting process can refresh without somebody rebuilding the same thing every month. That is the shift that I want you to make when you think about these technical skills. A tool by itself is not valuable. The problem that you can solve with the tool is what makes it valuable. Think about these two resume statements. Proficient in Python and pandas. Vanilla, boring. What the heck am I supposed to do with that as a hiring manager? Now compare it with this. Automated a recurring HR reporting workflow using Python and reducing a 4-hour manual process to under 5 minutes. That actually tells me something. I understand the problem, I understand what you built, and I understand the impact. And I can start imagining what you might be able to do and automate on my team. That is what you want your portfolio projects to do. You don't want the hiring manager thinking, this person just learned Python. You want them thinking, this person knows how to use Python to solve the problems that I already have on my team. And that is why I don't want you spending months trying to become a Python developer expert before you build anything. You take the analytical problems that you already understand and start asking, where's the repetitive work? Where am I manually combining files? When is using Excel starting to become a bottleneck in my workflow? That is where the skill starts becoming useful, because companies do not create data analyst positions because they just want more people to know syntax. They hire data analysts because they have problems that they need solved. You don't get paid for what you know. You always get paid for what you can prove. All right, now you can respond to all of this by adding Python to another study plan, but that would just put you right back to the trap that we started with. So here's a challenge that will actually make a difference for you. Don't buy another course. Don't download a giant Python roadmap that you always see on social media. Don't decide that you're going to magically master pandas this weekend. Pick one SQL query that you've already written and verified, just one, and then rewrite that entire query in pandas with that same data set. If you want help memorizing the syntax, use AI. But if you don't understand how a SQL operation translates into pandas, ask AI to explain the connection. But you make the decisions, and you verify the result, and you match the row count, match the totals, and if they don't match, don't immediately ask AI to fix everything. Find out why. Once they do match, explain your pandas code out loud without AI in plain English. If you can explain what every important step is doing and why you use it, translation number 1 is complete. Then do it again. Your goal is 5. 5 queries that you already understand, 5 pandas translations, 5 verified outputs, and 5 pieces of code that you can explain without hiding behind an AI-generated answer. That is a much better measure of progress than saying, I am 63% through my Python course, because finishing 63% of a course tells me how much content you consumed, but it doesn't tell me what you can do. And I know there's going to be temptation to make this bigger. You'll think one query is too easy. You should probably build a project. Maybe you should find a more advanced data set. Maybe you should do another certification first. No. One verifies translation, finish it, and then another. Remember, the goal is not to create the most impressive learning plan. The goal is to produce evidence that the skill is becoming yours. And after 5 translations, you'll have a different problem. You're no longer sitting there asking, hey, can I actually use Python? You have 5 examples proving that you can take analytical logic that you already understand, translate it into Python, verify the output, and explain why the code even works. Doing this will make you further along than most people who finish a 50-hour Python course. But knowing how to do the work and getting someone to believe you can do the work are 2 different problems. So now that you can translate what you already know into Python, let me show you the portfolio project that actually proves it to a hiring manager. It's right here, and I'll see you there.